It's amazing to think. Like, we've reached this point where AI can write articles and debug complex code and even have pretty nuanced conversations. It's easy to just assume, oh, they must actually understand what's going on. But what if that's like not the whole story? Like, what if their intelligence is more like, incredibly sophisticated mimicry? And when they encounter something that's even a little different from what they've seen before, the whole thing just falls apart.
Yeah, it really makes you think, like, what is going on in there? Even though these models are trained on these huge data sets, they might just be really good at spotting patterns and copying them without really getting the underlying idea. It really raises questions about, what intelligence really means in this context. Are they thinking like us? Or are they doing something completely different?
Exactly. And that's what we're diving into today. We're looking at this new study called Get This Recitation Over Reasoning. How cutting-edge language models can fail on elementary school level reasoning problems. Come on, elementary school.
Mhm.
This research is from Kayan and their team, and it was just published on April 2nd, 2025. And it's got some really surprising findings. Like, it makes you
Yeah.
question how smart these LLMs, these large language models, actually are.
I mean, yeah, that title is a bit of a head scratcher, right? Elementary school. We're talking about AI that can pass like graduate level exams. It seems kind of crazy, but that's what makes this research so interesting. It makes us think maybe all the amazing things that LLMs can do, maybe they're not always coming from like actual understanding and real problem solving.
So we're on a mission today. We're going deep into this study. We want to see how the researchers did it, what they discovered, and what it all means for the capabilities and, yeah, the limitations of AI,
Yeah.
because it's everywhere these days.
It's everywhere. Okay, so the big question here is when an LLM answers a problem that, needs some thinking, is it actually thinking? Like, is it applying logic and figuring things out based on the situation? Or is it more like it's just pulling from this giant library of data in its memory, like just remembering and tweaking patterns it's seen before? Is this true reasoning, or is it more like really advanced recitation?
So how do you even begin to separate those two things? How can you tell if an AI is thinking or just remembering something similar?
Right. And that's where this research is so clever. The team created this new benchmark. It's called RoR-Bench. Short for, you guessed it, Recitation Over Reasoning Benchmark. It's a test designed to expose whether an LLM is truly reasoning or just mimicking, like, really well.
Okay, I am intrigued. What's so special about this RoR-Bench? What kinds of problems does it use?
It all comes down to the structure. It's all about pairs of problems. So first, you have your original reasoning problem. It's usually like elementary school level. Pretty straightforward. But then, and this is the key, you have a slightly modified version of that same problem. Now, this tiny change, this tweak, it completely changes the logic you need to solve it.
I see. So it's not about just changing the numbers in a math problem. It's like changing a rule or a condition that forces the AI to think in a totally new way.
That's it. They didn't just swap numbers, they wanted to make sure the AI needed a whole new approach to solve the modified problem. And they kept the changes tiny, like
Yeah.
just a word or two different. So you have these two problems that look almost identical, but the thinking needed is completely different. This way, they can isolate whether the LLM is truly thinking or just recognizing familiar words.
That's really clever. How many of these pairs did they actually come up with for RoR-Bench?
Well, RoR-Bench is pretty comprehensive. It's got 158 pairs of text-based reasoning problems and 57 pairs of image-based reasoning problems. And the text problems cover all sorts of stuff. You've got your math like arithmetic, geometry, probability, combinatorics, and then other types of reasoning like optimization puzzles, common sense questions, deduction, even some basic game theory.
Wow. So creating and checking all those problem pairs, that must have taken a lot of work.
It did. They had a whole team of people. 17 people created the problems and their modified versions, and then 6 others reviewed each pair really carefully. They made sure the modified problems needed new ways of solving, that there wasn't any confusion in the wording, and that the changes were small enough to really zero in on the AI's reasoning skills.
Okay, so we have this really well-designed test. Now, the big question,
hmm
how did the best AIs do on it?
And here's where things get really interesting. They tested 23 of the most advanced LLMs on the text part of RoR-Bench. Big names like OpenAI's o1 and the latest GPT 4.5 preview, DeepSeek R1, Google's Gemini 2.0 Pro, Anthropic's Claude 3.7 Sonnet, the whole all-star team.
Wow, the best of the best. So How did they actually score these AIs? Was it just about getting the right number, or was it more nuanced than that?
They wanted to be really thorough, so they used another powerful language model, GPT-4o, as
Sure.
like a judge. They gave it the original problem, the answer from the AI they were testing, and the correct answer. Then GPT-4o basically said, yep, correct, or nope, wrong, a simple pass or fail based on logic.
Ah, so it was like GPT-4o was the referee, making sure the answers made sense,
Yeah.
and the result. What did they find?
Get this. On average, these top-of-the-line LLMs did over 50% worse on the modified problems compared to the original ones. And some of the best ones, like OpenAI-1 and DeepSeek-R1, they bombed even harder, like over 60% worse.
A 60% drop, just from a small wording change. That's a massive difference. It really looks like they rely heavily on recognizing patterns, and when you mess with those patterns even a little, they just can't handle it.
Yeah, it's pretty clear. And if you look at Figure 1b in their paper, there's this graph that shows it really well. It's like this dramatic cliff between their accuracy on the original problems and the modified ones.
I wonder if they're maybe misinterpreting the changes as typos. Like maybe they see the modified problem and think, oh, that must be a mistake. I'll just answer the original one.
That's a good point, and they actually thought of that. They used a special prompt called the forced correct prompt. They told the LLMs, hey, the problem is correct, don't try to fix it, just answer it as it is.
So they told the AI to take it literally. Did that help?
You'd think it would, right? But it didn't make much difference. Even with that instruction, they still performed about 45% worse on the modified problems on average. So it's not just about typos. They really do struggle with reasoning when things change even slightly.
But hold on, didn't you say that sometimes that forced correct prompt actually made things worse?
Yeah, sometimes. It's in Appendix B.5 of the paper. There was this one case with Gemini 2.0 Pro where it had to figure out if a game was fair. But because of that forced correct prompt, it got all hung up on the definition of fairness, like super literal. It totally missed the point of the problem, which was to analyze the game itself. So yeah, telling AI to take everything literally can backfire sometimes.
Makes sense. What about those chain of thought prompts where you encourage the AI to explain its thinking step by step? Did those make a difference?
They tried that too, hoping it would encourage more in-depth reasoning. But unfortunately, even with those prompts, they didn't see much improvement on the modified problems. So even when they explain their thinking, that tendency to rely on old patterns still sticks around.
So the text-based problems show this recitation over reasoning pretty clearly. What about the image-based problems? Did they see the same thing with AIs that can understand pictures?
Yep. They tested 15 state-of-the-art vision language models, VLMs. These are models that handle both text and images. They tested big names like GPT 4.5 Preview, OpenAI-01, which can do both text and images, Gemini 2.0 Pro, and Claude 3.5 Sonnet.
Same setup as before with GPT-4o as the judge.
Exactly the same. And you guessed it, the VLMs also showed a big drop in performance, over 35% on average, when they were given those tweaked image
A
problems.
bit less than with text, but still a huge difference. Any interesting observations from the image tests?
Well, the OpenAI models, they were actually really good at the original image problems, but then they completely tanked on the modified ones. The researchers think this might be because they're too good at recognizing those specific images. It's like they memorize the answers instead of learning the concepts.
Oh.
A lot of the original problems involved these famous visual effects like mock bands, so maybe they just focused on those specific patterns and missed the subtle changes.
So being good at identifying known images actually made them worse at handling anything new.
That's a fascinating insight into how they learn, or maybe don't really learn, in a way that lets them generalize.
Exactly. It's like a trade-off. Training them on huge amounts of data makes them good at what they've seen, but it can make them bad at adapting.
Didn't the researchers also try to use in-context learning to help the AIs reason better by giving them examples of similar problems?
They did. They tried what's called few-shot in-context learning, or ICL. It's basically giving the AI a few examples of the task right before the test. They tested two ways of doing this. First, they gave the AI the original problem and its solution as a single example, hoping it would help them see the underlying logic.
In the second way.
In the second way, they used examples of other modified problems and their solutions, like one example or even 5 examples. The idea was to see if seeing those tweaks would make them more sensitive to these slight changes.
Did it work? Did the in-context learning fix the recitation over reasoning? It did help a bit. You can see the details in Table 3 of the paper. But even with those examples, their accuracy on the modified problems was still way lower than on the original ones, like over 30% lower on average. So just giving them a few examples, even good ones, wasn't enough to fix this deep-rooted problem.
And they even have an example with a classic river crossing puzzle to show this
Yeah.
figure.
In Appendix 8.3, they gave OpenAI O1 an example of the original river crossing problem and its solution. But then, even with that, it still got tricked by the modified version. It just tried to apply the same old strategy, even though it didn't work anymore because the rules had changed.
It's like they get stuck in a rut. They see a certain type of problem and try to jam any new problem, even if it's different, into that same mold.
Exactly. And this leads us to one of the most interesting and maybe even scary findings of this whole study. They call it the mental seal of solvability. They got the idea from this sci-fi book, The Dark Forest by Cixin Liu.
Oh, yeah. The idea that there's this deep-seated belief that you just can't shake. How does that apply to the LLMs?
Well, they put some special problems into RoR-Bench. They're called no-solution problems. These are modified problems that are impossible to solve because of the way they're worded. They wanted to see how the AIs would handle a problem that just doesn't have a right answer.
My guess is they didn't handle it very well.
You're right. They almost completely failed to spot these impossible problems. Instead of saying, hey, this doesn't make sense, they just made up answers. And get this. None of the AIs, unless they were given some special help, did better than 15% accuracy on these no-solution problems. It's like they're programmed to believe that every problem must have an answer, no matter what.
That's kind of disturbing. If they can't even recognize when something is impossible, how can we trust them with real-world problems that might be totally new or unclear?
It's definitely a concern. So they tried to break this mental seal of solvability by using that force correct prompt again, and by giving them an example of a no solution problem as a hint. They even tried both at the same time.
And did that help? Could they break the seal?
For some, it did. GPT 4.5 Preview, for example, got a lot better at spotting the impossible problems when they did that. But others, like DeepSeek R1 and some of the smaller Quinn models, they just kept making up answers. Stubborn, I guess. You can see the details in Table 4 and Appendix B.4 of the paper.
So to sum it up, the big takeaway from this recitation over reasoning study is, well, pretty big. It's about more than just tweaking a few things.
It's huge. What we're seeing is a major problem with how these LLMs work. They're not really reasoning, they're just reciting. And they completely fall apart when you make even tiny changes to problems.
And this wasn't just one model or one type of problem. It was across the board. All these top AIs in both text and images showed the same problem.
And those fixes they tried, like special prompts or giving examples, they only helped a little. The gap between their ability to handle original problems and the slightly changed ones was still there.
And that whole mental seal of solvability thing, that's a whole other level of worry. It's like they're blind to the possibility of something being impossible.
Yeah, it raises serious doubts about how reliable and trustworthy these AIs can be in the real world. They're going to run into situations that they've never seen before, and if they can't recognize when something just doesn't make sense, that could be a big problem.
Now, the researchers did mention some limitations to their study, right? Like things they couldn't fully explore this time.
Right. One thing was that the RoR-Bench was mainly in Chinese, so maybe that gave a slight advantage to the Chinese-developed AIs, but they did do some testing with English translations, and it looked like the same problems were there, so it probably isn't just a language thing. But expanding the benchmark to other languages is definitely something they want to do in the future.
What else did they say they want to investigate further?
They really emphasize the need to find better ways to make these LLMs actually reason, not just recognize patterns, like maybe trying new ways of training them, different model designs, or even finding ways to give them more symbolic reasoning abilities. They also talked about how it's still hard to tell the difference between true reasoning and just super advanced pattern matching. Like, even if it looks like it's thinking, is it really?
It's almost like a philosophical question, right? What does it mean for a machine to think? But with these AIs becoming so prevalent, it's a question we really have to answer. So after this deep dive into the recitation over reasoning research, I think it's pretty clear. We need to be careful about overestimating AI.
Totally. They're powerful tools, but they're not as smart as we might think. This research shows us we're not at true AI intelligence yet. We've got these really sophisticated mimics, but they're not really understanding the world or thinking for themselves.
This study makes you rethink everything about what we consider intelligence in AI. It's not just about what they can do, but how they do it, and whether they can truly adapt and handle new situations. I mean, if you're interested, you should check out the RoR-Bench dataset yourself. It's publicly available on Hugging Face. There's a link in the paper. It's pretty mind-blowing to see these seemingly simple problems that even the best AIs can't solve. Lots to think about.